Alright, so today I'm going to present 14-3. I'm going to do only the first part, and the second part, Hyungsu is gonna do it in Monday. There are two vocabulary that I'm going to cover. It's solvation and heat of solution. And solvation is basically when solid particles are being surrounded by solvent particles. So basically, I'm going to give you an example of NaCl. So let's say that's NaCl. It's very simple, but then okay, never mind. I'm going to draw water molecules. So as you probably know, this part of H2O and this is Na. So as you probably know, these two are oxygen. No wait, these are hydrogen molecules. So these ones are minus and
No, plus.
okay.
Positive.
And this one's negative. So let's say this is Na. So all of them are positive, and all of them are negative. So when salt is dropped into the solvent mixture, which in this case is H2O, the H2O molecules are gonna go in. They're gonna take, let's say they're gonna take an Na, sodium. So they're gonna put the sodium in here, and let's, for example, make another one. And they want to take a Cl this time. So, no wait, that's Cl, I'm sorry. And they want to take an Na molecule. So, then they're gonna put it here. So basically solvation is, so water, the solvent's basically taking the solid molecules and then they're forming like a bond. So like they're basically surrounding the solvent. The solid. And heat of solution is basically the energy that is created when solutes are dissolved. So yeah, this is the definition. It's also called hydration, apparently. And so basically the dipoles of the water are so the attraction between the water molecules and the dipoles of the water and the ions of the crystal is higher than the power between the crystals itself. So it's basically the force of the crystal isn't strong enough to hold itself, so it gets broken down. A very good example of the opposite of this is gypsum, and it's on the book. So gypsum's attractive forces are so strong that it basically cannot be like broken down, basically. And probably if you break it like into small pieces, it can, but in this case, it cannot. So this is what I was talking about. They're going to surround a solute, and these are obviously solvents. They're gonna basically take one until it becomes very spread out. So in this case, sucrose is obviously sugar. So in sugar, it's C12, H22, and O11, I think. So basically, these are water molecules, and they're basically taking one off, and then again they turn around, one off, until it becomes all dissolved. And another exclusion from this is oil. Oil is, I think, they're made up of hydrocarbons, but they're not specifically made of something. They depend on what they came from. So oil is typically non-polar, and obviously water is polar, so polar with polar it blends well, but polar with non-polar is not gonna blend well, and oil is gonna stay on top of the water. So obviously when solvation occurs, energy is released or energy is absorbed, and that's heat of solution. And there are three factors that affect solvation in general. The first one is stirring or shaking, which in the book there's an example of iced tea. Let's say this is iced tea, and sugar, a cube of sugar. So obviously, when there's a big chunk of sugar, obviously it's hard to break down. It's obviously hard to go inside and start breaking it down. So if we stir it around or shake it, it's going to start to spread out very easily. And to begin, and this is the first one, stirring and shaking. And the second one is just start off from very small chunks so that the solvent can dissolve it pretty quickly. The third one is having a very warm solution, very warm solute, and adding the sugar molecule. So basically, so the basic three things that you need to know is that by stirring and shaking, you can speed up the process of solvation. By breaking the solids into very small pieces, can speed it up as well. And as temperature increases, the rate of solvation increases too. So if it's very cold and you add like maybe sugar molecules, then it's gonna be a very slow process. Thanks.
TM.
Okay.
Oh, yes.
Very good.